Hi, this is a video for assignment 3 of Harvard's CS50 game development course. This time we'll be looking at match 3, which is a tile matching game. This game rests in the same subgenre as some well-known titles such as Bejeweled or Candy Crush Saga. The original has limited functionality, and the assignment focuses on adding a lot of new features. In the original, one uses the keyboard to move the highlight around. Once a tile is selected, it can be swapped with an orthogonal adjacent tile, irrespective of whether such a swap results in a match. If 3 or more tiles of the same color end up in a line, then all those tiles are removed from the board. Once this happens, new tiles are spawned at the top and drop down to fill in the gaps. The assignment has 4 main objectives and 1 optional one, and we'll go through them one by one. If a move results in matches anywhere on the board, the player gets 1 second added to their timer as a reward. It doesn't matter if you clear 3 tiles, 4 tiles, or a whole row at once, the reward is always 1 second. So we have 18 colors and 6 varieties of tiles, and we need to ensure that we don't overwhelm the player with all of them at once. For this, I started by passing the level variable into the board constructor. For varieties, I just made sure that new varieties are introduced every few levels, eventually capping off at 6. This ensures that we start off with flat tiles and get new ones on the way. Each tile with a pattern is worth slightly more points, which helps in reaching the goal at higher levels. For colors, I made a table that decides what order the colors appear in. Initially, the colors contrast with each other for better visibility, and then slowly new colors, which are similar to the previous ones, are introduced. A match that includes a shiny tile destroys a whole row, and the points for each tile in that row are totaled. I set a flag to decide whether a tile will be shiny, and in this build there is a 10% chance of it being so. Once it spawns, it comes with little sparkles at the corner, and when destroyed, it takes along with it the whole row, followed by some dusty particle effects. I implemented this by differentiating between vertical and horizontal matches, and made a function that renders the particle effects accordingly. I took the original swapping code and put it in a function. The new swap function takes in 2 xy coordinate pairs, which are basically the grid values, and swaps the corresponding tiles. As a side note, swapping using grid values is a much more powerful implementation than just swapping regular tile objects. Also, I modified the calculate matches function in the play state to take 2 xy coordinate pairs. We supply the coordinates of the tiles we just swapped and check if this results in a match. If not, we swap them back and animate their movements using tween. As now the player has less freedom of swapping, we need to check whether any possible swaps exist. I made a function that does so by simulating all possible swaps in the background. If there are none, then the board resets with a little reset animation. One way to implement the reset was to swap tiles around the board. But as the game has no power-ups and the distribution of tiles, including the shiny ones, is more or less fixed, the simpler implementation was to reinitialize the board. The final and optional task was to implement mouse controls. To do this, first I got the cursor and set the XY coordinates such that they represented the grid value of the cursor's position. I delegated the handling of mouse controls into 2 functions. One that handles the operation before a tile is selected, and the other one that comes into action when selection happens. After correcting for offsets, the player can use the mouse to move the red highlight around. On clicking the left mouse button, the tile gets selected and the swappable tiles get highlighted. And this is where the second function comes in. The player can deselect if they click anywhere except on the 4 highlighted tiles. If any one of the highlighted tiles are clicked on, they undergo a standard swap. This function is also responsible for drawing the blue squares on the board while taking care of the edges. This is mostly it for assignment 3. The link to the code and the exe is in the description below. Next time, we'll be looking at Mario. So that's exciting. See you then. Bye bye.